Great, thank you, and welcome everybody. Thanks for coming. I'm Marcos Fajardo. I'll tell you a little bit about where I come from and how I got into rendering and things like that in a second. But let me show you just a little 30-second teaser of work that we've done with Arnold over the last year or so. Right. So, like I said, I'm just going to tell you a little bit about where I come from, where Arnold is today, and what we're working on. And maybe you guys will you want to ask me some questions later. I'll try to go very quickly today. So, how I got into rendering. I studied computer science in Malaga University in Spain many years ago. I don't know, 20 years ago, whatever. And I quickly, I love mathematics and physics, but I didn't know what to do when I was that young. I didn't really know what I wanted to study. So I somehow ended up studying computer science, and one thing led to another, and I discovered ray tracing when I was studying computer science, and that was to me, they were in university they teach you all this physics and mathematics and all this stuff, and it's kind of boring. But when I discovered ray tracing, I was like, wait. So all those equations and all those boring computer science stuff can be actually used to make images and new worlds and virtual worlds, and I was completely blown away. And that's how I started doing research on my own on ray tracing, and that's how I could apply all those equations and all that knowledge that I was learning in computer science to produce beautiful images. So for me, that was great. I love what I do. I love mathematics. I love physics, and I love creating beautiful images. That's why I really, that's where my passion comes from. And I'm sure many of you can share that passion, just creating beautiful images using mathematics. So very quickly, I learned that the prevailing computer graphics rendering techniques were, a little not obsolete, but they were not as good as they could be. So I started doing research on ray tracing and path tracing. I discovered one company in New York, Blue Sky Studios. Back then, they were probably the only company that was really using ray tracing. So they showed me, I visited them in 1998 or so, and they showed me some of the images that they could generate with their ray tracer, like this one over here. This is one of the early first images where you could see bounce lighting. You get a strong light hitting this yellow wall, and this light bouncing from the wall into the ground and illuminating the spheres. And back in 1997 or whatever, when I see these images, like I said, this was new. Nobody was doing stuff like this. This was completely blew me away. And here's another example. They could light things not just with point light sources, but also with a sky, something that nobody had ever done before. And when I saw this image back then in 1998, again, it just blew me away, and I really, really wanted to replicate the results that Blue Sky Studio was getting with their render. So that's how I started thinking about writing a new render that would use those ideas that these guys, Blue Sky Studio, pioneered. And I tried to, my obsession was to replicate this image. And for a year, I was depressed. I didn't know how they were doing it. It looked like black magic to me. But until I discovered some research papers from the 80s by Jim Kajija and some other researchers, and I was like, okay, now I know how these guys are doing it. And that was Monte Carlo path tracing. So that's the epiphany that I had many years ago. I connected the dots, and I started developing my own render. I was very happy when Blue Sky Studios got an Academy Award for Bunny, a short film that they worked on in 1998 or so. To me, that was a signal that Monte Carlo path tracing was going to be the way of the future. So yeah, it took me a year to develop my own render, Arnold. And a friend of mine did this animated short, Pepe, in 1999, that blew many other people away because nobody had access to this technology. Like regular users at home, they couldn't really use this render back then. So when we showed that this could be done in a home computer, that was quite something, and people got really excited. And I started noticing that people really wanted a fast ray tracer. So I got more focused, and I started working harder and harder on finishing my render. And then the next year, one of my other friends did this short film called 50% Grey that was nominated for an Academy Award. So for me, that was just, okay, this is going too fast. I just wrote this little render, and I've got all these people excited around the world, and a friend of mine did an Academy Award nominated short film. I didn't even believe that was happening. It was all very cool and happening very fast. Shortly after, I moved to Los Angeles to work for Paul Levesque at the University of Southern California Institute for Creative Technologies. And Paul was, many of you probably have heard of Paul Levesque. He's a truly pioneer in computer graphics. And I learned many, many things from him, high dynamic range imaging. He really wanted to use global illumination to do the Parthenon short film, where we had to go to Athens and scan the whole Acropolis with laser scanners and all kinds of different types of scanners. And he wanted to bring a vision of the Parthenon. And for that vision, he really required global illumination. And back then, global illumination was very expensive. So I was very happy to work with him on making Arnold fast enough that he could do this short film. And I learned many things with Paul. And a couple of years later, I moved to Sony Pictures Imageworks in Los Angeles, because they needed to do this film, Monster House, that again required a look that could not be achieved with the renders that were available at the time. So I started working at Imageworks, and I tried to make Arnold fast enough so that it could be used on a full-length feature film. That was an incredible challenge. When I started working on this project, I wasn't sure that we were going to make it. But Sony Imageworks, those guys believed in the technology, and they helped me. They gave me a bunch of engineers, and we worked really hard on Arnold and make it, a lot faster, a lot better, and production capable. Arnold was missing many features for making movies, and a lot of those features originated at Imageworks while I was working there for 3 years. So Monster House in particular was I believe it was the first film that was entirely rendered with brute force path tracing, with ray tracing. So there was no global illumination caching. It was all computed per pixel. We had an unbiased estimate of the illumination integrals in every pixel. That was something that has never been done before at this scale, at a scale of a full feature film. And then Imageworks was really happy with the results of Arnold for Monster House, so we started working on other movies like Cloudy with Chance of Meatballs and a bunch of other movies. Arnold really took over their pipeline, and everything coming out of Imageworks since then has been rendered with Arnold, both animated films and visual effects films. I think Alice in Wonderland was the last movie that I worked on when I was there. Now, around that time, in 2009, I moved back to my country, Spain, and I wanted to found a company because the software had been evolving and getting bigger and bigger, and I couldn't continue work on the render on my own. I needed a team, a bigger team. So I set up the company, Solid Angle, and I started hiring people slowly. At the beginning, we were just 2 people, and until recently, we were 30 people. And we have people in different countries. The offices are in Madrid and London. Things were great. We've been doing, again, scaling the software, making it bigger, making it more robust, making it faster for a few years. And this year, as you probably know by now, we joined forces with Autodesk in February of this year. So we are now part of the Autodesk family, and we're going to continue to make Arnold better, faster, bigger, so that you guys can create amazing content. That's the intent. Now, while at Solid Angle, after Sony, Arnold started to become more popular. Everybody wanted to use it. So a lot of different companies around the world adopted Arnold for visual effects and animation. Here's some images of different movies that we work on in the past few years. the interesting thing is that as a ray tracer, Arnold was probably the most efficient, a memory efficient ray tracer. So many of these projects had a lot of geometry, billions or millions or trillions of polygons, and no other ray tracer really could ray trace that amount of geometry. So Arnold was the go-to renderer if you were doing something of a very large scale and you needed ray tracing. And the interesting thing is that, many years ago, very few people were using ray tracing. Everything was done with other algorithms like rasterization. So lighting was hacked. You had to do a lot of point lights, and there was no bounce light. But today, everybody is using ray tracing because with ray tracing, all of these effects, bounce lighting, soft shadows, surface scattering, all of these things happen naturally, and they're the same paradigm and the same, you're using the same techniques, like basically ray tracing and sampling. So again, Arnold was the only renderer that could render this type of complexity. That's why it's been adopted by so many studios. One thing in particular that was very difficult to ray trace was fur, hair. We had to optimize our hair, our curves primitive. Arnold has Arnold can render polygons, but also splines, hair splines that are perfectly ray traced and they're perfectly curved and they're amazingly beautiful. So because of that efficient curves primitive, we can render highly complex characters. So that's another thing that Arnold has been famous for, rendering huge amounts of hair. More movies where we use Arnold. Okay, so that's until today. Now, one thing I wanted to mention, we've always believed in multi-vendor pipelines, in supporting whatever tool the studios are using. So many studios today are using perhaps Maya, Houdini, Cinema 4D. There's like different departments within a studio, and they all need rendering. So early on, I decided that, okay, we're going to add support for Arnold in all of these different packages so that at both small studios and big studios, you can easily use Arnold regardless of what package you're using. So today you can find Arnold, you can use Arnold in Maya, but also in non-Autodesk applications like Houdini, Katana, Cinema 4D. And I think yesterday we just released that we're going to have a plugin for CStudio Max. In fact, you can actually download it from our webpage today. So yeah, again, I just wanted to show my commitment to all of these different applications. We're going to continue to develop Arnold and support it and enhance and optimize it for all of these different platforms, because I think it's important that all of our customers can use Arnold across all of these other applications. So that's not going to stop. We're going to continue to make Arnold for all of these platforms. Here are some examples. This is an image from Captain America, the latest Captain America film, done in Munich by Trickster, done with Arnold for Katana. And here's another example. Here's a short film that was released today, by Trevor Kerr, done with Arnold for Cinema 4D. The cool thing about this short film is that the environments are all full CG. They're hugely complex. There's like billions and billions of polygons in there, done by one person. So this is a very cool short film. Let's see if you like it. was a little example of something that can be done easily today with Arnold. Now, I'm going to talk a little bit about what we are working on, the next release of Arnold. Now, some of these things are still being worked on. They might make it to this new version or not, but just going to show you a little preview of what we're working on. My main focus has always been performance and research. And those of you who know a little about rendering know that ray tracing is all about sampling and integral equations. So that's what our focus has always been and will continue to be. We need to still make the render faster and more efficient. There has to be more research done on make the render faster, and that's what we enjoy. So that's what I want to continue to do, for as long as I can. So a few things that we're working on. We're going to change our shading system. For many years, we have had a C++ based shading system. So the way you program shaders in Arnold is using C++. That's changing in the next release of Arnold, and we're going to have support for OSL. I announced this last year, and it took us a little longer to finish than I thought, but it's almost ready. So you can now write shaders both in C++ and also in OSL. And the cool thing is that you can combine OSL shaders with C++ shaders in any way you want. So you don't have to use one or the other, you can combine them. So depending on your pipeline, you might want to do that or not. Now performance, like I was talking about sampling, but that's like the mathematical part of how to make a render faster. There's another part which is the systems engineering part, which is just low-level programming, like how to write super efficient code, how to make your code scale to machines with many CPUs and threads. When I started working on Arnold, well, the first version was not multi-threaded many years ago. Very soon we had a machine with 2 processors, so I had to add multi-threading so you could run Arnold on 2 processors and get 2x faster rendering. Today we have, for example, we have a machine at the Madrid office with 64 threads. So, running your algorithms on a machine with 64 threads is a lot more complicated than running it on a machine with 1 thread. If you just do things naively, your render is not going to scale to those 64 threads, so you're not going to be 64 times faster. The holy grail of scalability, of CPU scalability, is to scale linearly with the number of processors in your machine. So that becomes more and more difficult as the machines have more and more cores and threads. Like I said, today we have machines with 64 threads. Maybe next year we'll have machines with 120. Actually, today some of our customers have machines with 160 threads. So it just keeps going up and up and up. So we need to make sure that Arnold continues to scale very efficiently. And it's actually very difficult to do. It's not easy to program, to write an algorithm that scales very well as you continue to add more and more threads to the machine. So that's one of the things that we are going to continue to do, just make it faster and faster with big CPUs, with many cores. Now, also the memory usage. I was saying before that Arnold is a great render for scenes that are really complex with millions, billions, or even trillions of polygons, but that's never enough. So every year, our customers require more, bigger scenes, more complex scenes. No matter how fast we make the render, no matter how efficient we make it, they'll just find ways to throw more polygons or more hairs and more things to the scene. So we have to continue. Somehow we have to find ways to make the render even more efficient. So a memory in particular is really important because if you can't even load your scene in memory, well, you can't even render it. So we're going to continue to do a lot of work on that. Another cool thing that we've been doing lately is volume rendering, clouds, smoke, fire, things like that. It's really difficult to do really high quality volumes and fog and clouds when you want to do a global illumination solution inside the volume. We call that multiple scattering. And we've done a lot of work recently on that. We're still trying to make it faster. It's gotten to the point where you can actually use that now in production. Like just a few years ago, it was impossible to use multiple scattering, global illumination in volumes. Today, it's actually possible. It could be faster, so that's why we still need to do more research and more optimization on volume rendering. The preferred volume format that we use is OpenVDB, which is a volume storage or API developed by DreamWorks. And we are very proud of our OpenVDB implementation, and it's just going to keep getting better and better. What else? Also, we're taking the opportunity in Arnold 5 to rewrite big chunks of the public API. Arnold, for those of you who don't know, Arnold is not just a standalone render, it's not just a plugin for Maya, it's also a programming library. You can use Arnold to build applications, to write applications on top of the Arnold library. For example, if somebody wants to write an interactive application with rendering, you can use Arnold and build your own application. That's really cool. Not many people know about that, but it's really cool. So because of Arnold being a library, we can plug it into all of these applications that I was mentioning before. And so we're going to make that API much easier to use so that it takes less time for developers to write Arnold applications or integrate Arnold into their pipelines at the Visual Effects studios. So yeah, that's a little bit about what we're working on. There's a few things that I probably can't tell you, but that's just a quick snapshot of some of the things that we're working on. I'm going to go into more detail into some of these things. I was mentioning before sampling, so the sampling algorithms, the mathematics behind sampling. We're always working on improving these mathematics. Here's an example of a technique that we presented today here at SIGGRAPH. On the left, you can see the standard sampler that we've been using until now in Arnold 4. On the right is a new sampler that we are experimenting with now. It uses a technique called blue noise dithering. And I hope that you can see the difference, that the right image should look a lot cleaner, should look a lot more pleasing to the eye. Even though if you measure the error with a reference image, the error is actually the same in both images. We found a technique that even though, like I said, numerically there's the same error in the images, but the error is distributed in a way that it looks more pleasing to the eye. So it's a bit of it's a funny thing. So, but again, the error is the same in both images, but the one in the right looks better, doesn't it? So that's just by doing more and more mathematical research, we find ways to improve what the render can do. And that's what gets me excited every morning when I wake up. Well, sometimes I wake up in the afternoon, but this is really what my team at Solid Angle is really good at, just making the render more efficient, finding ways to use mathematics to improve the render. It's all about the mathematics. So that's why our logo for many years has always been this rendering equation, because this equation lies at the core of everything that we do. So, and that's, I'm not going to get tired of saying that ever, but this equation, is what drives us. So that's one example of something that we're working on. Here's another example. Again, by using better, more advanced mathematics and better sampling, we can reduce the noise in our renders. Reducing the noise in your renders is great because they take less time to render. So, like the image on the left has been probably rendered in, I don't know, maybe it took 1 second or whatever. The image at the right took the same amount of time, but it looks better. It has less noise. So that means that with fewer samples, with the same computation, you get better, high quality images. Pretty hard to see what's going on here. What this is a disk area light. See if I don't. There's like a disk area light here, perpendicular to the ground plane. So we found ways to sample that area light more efficiently. Here's another example with a different type of area light. And again, the technique that we use right now generates a lot of noise, and we found a way to render the image in the same amount of time, but with a lot less noise. So that's great. Another example, in this case, here's a rectangular light, again, perpendicular to the ground, right here. This is the current technique we use in Arnold, and that's one of the techniques that we're working on. We found a way to sample this area light in a way that completely removes noise in areas that are unoccluded. So the only remaining noise in that image over there are the shadows. So, it's a pretty clear improvement, I hope. So again, thanks to mathematics. It's all about mathematics. Now, another thing that I wanted to show you guys, an experiment that we've been working on for a year. we were trying to get Arnold to run on the GPU. For those of you who don't know, Arnold today only runs on the CPU. GPUs are becoming faster and faster and more powerful. There's an incredible amount of transistors and threads in GPU, so it can make sense to take advantage of that. So we started to experiment with GPU rendering. Here's an example. Here's a comparison. We took this scene. We tried to render in both the CPU, or different CPUs and the GPU, and well, yes, GPUs are obviously much faster. In this case, depending on what CPU and what GPU you compare, we're seeing speed-ups like 50 times faster or 5 times faster. Like if you compare this M6000 GPU from NVIDIA to an Intel Nehalem CPU with 4 cores, it's like 50 times faster. Of course, it's a slow CPU and a very fast GPU, so there's like a 50 times faster difference. If you compare that with a more modern CPU, like a Xeon with 32 cores and 64 threads, well, the difference is still significant. It's 5 times faster. So, of course, CPUs and GPUs, there's different price points, and it's kind of hard to compare CPUs and GPUs because there's a wide range of pricing. Like you can buy a super expensive GPU or a cheap GPU, and the same thing with CPUs is true. So depending on what you want to compare, those numbers can change, wildly. But it's pretty clear that GPUs are faster, and we want to take advantage of that. The cool thing is that both the CPU render and the GPU render will take the same input. So, it should be very transparent to the user whether you want to use the CPU or the GPU. Still working on that, but it's looking very promising. Now, in this case, this scene had only polygons. We tried to do an experiment with curves, with fur rendering, and in this case, the difference is not as dramatic. You get like an 8x or 10% speed up, but we're still working on that. So, just wanted to show you guys a little preview that we're actually working on GPU rendering, and hopefully we'll have an actual product that we can ship at some point. So I think that's about it. I just wanted to show you guys a preview of some of the things that we're working on. And yeah, that's about it for today. I think what we're gonna do now is, if you guys have any questions about Arnold, about the future, about the way the Autodesk acquisition is going, or anything like that, I'll be happy to take questions. So that's it. Thank you. Thanks. Maybe move to the microphone over there.
Thanks, that was great. Just have one question. I come from a freelance background, and one of the appeals of, say, V-Ray was that you could, if you're doing a print resolution image, you could divide it up over a bunch of machines, and it was a bucket render, or it would scale dumbly. The thing with Arnold is that when you do multi-frame or you do a single frame, it doesn't do that distributed type of rendering. I'm wondering if that's something that you're working on.
Yes, so it doesn't do that yet, but we want to add that feature. We want to make it transparent so you can just say, okay, just distribute it over my local network, and yeah. So that's, you're right, we don't support that feature yet, but it's not fundamentally difficult to implement. We just never. The thing about Arnold is that we were targeting the visual effects and animation, industries where that feature wasn't particularly important. But as we get Arnold into more and more types of users, that becomes important. So yes, we're going to be working on distributed rendering.
Great, thanks.
Thanks.
Hey Marcos, great talk. Great to hear about the OSL and Arnold 5. Will that support closures, or will it just be for doing patterns?
So we have, let me see, texture patterns for sure, and we are also working on supporting arbitrary closures. So the prototype works, but we need to make sure that that is really solid and robust before we actually make that into an actual feature. But I guess the answer is yes, we can do both patterns and closures.
Okay. Great, that's great. And could you do like arbitrary ray tracing inside the OSL as well, like do the trace calls?
There's a trace call.
Right.
We wouldn't recommend you abusing that
Yeah.
trace call, because then you're back to the same original problem. Like OSL is supposed to solve the problem of shader writers, like writing integrators within a shader. But with a trace call, you can kind of like write your own integrator.
Yeah, exactly. You kind of break the system, but clients tend to ask for funny things all the time. So yeah. Great, thanks.
Sure.
Marcos, I was curious to hear about your take on VR and particularly like light fields, and then also what the no zone people were doing with Presence Z, that kind of stuff. Do you see Arnold moving in that direction or exploring that more? Or?
Sure. Yeah. I mean, for light fields in particular, so computing a light field is just firing a lot of rays. You define a volume and you need to compute, all of this light field data structure in there. So you can use the Arnold API to compute those rays. You can write a program that does that. But there might be faster ways to do that. So we're going to explore how to make that even better. Even if you can compute that light field, then you have to store it. And these things can be very big, very large, depending on the volume that you're trying to simulate. So I think, interestingly, it's not so much about ray tracing. To me, the interesting part of that problem is the compression that you're going to have to design so that amount of data is manageable. And then once you have that light field, and how do you display and reproduce it? So I don't think we're going to get into the display part, but at least Arnold should be able to compute light fields. And for that, I think, in a small machine, I don't think you're going to be able to compute very large light fields, but using the cloud, that's going to make, it really easy to compute big, large light fields.
Thank you.
And as far as the no-zone presence system, I've seen it in action. It looks amazing. But that's sort of a limited light field. So basically what they do is they render a big, deep image, which is essentially a point cloud. And they use that to reproject that thing into the display. But it works really well, so as far as I can tell.
Great, thank you.
Any other questions? Come on, don't be shy. When it's ready, but it shouldn't. It's getting there. I probably can't mention a release date, but yeah, I can probably. If you want to try an early alpha, then talk to me.
Hey, I know that Maya 7, the new beta is released with Arnold, and I'm just wondering regarding licensing, if there is any announcement of how Arnold is going to be shipped with the Maya, in terms of the licensing.
Can you speak a bit louder?
Yes, sorry. Just asking about licensing regarding Maya.
Licensing?
Yeah.
Okay. I think that question is above my pay grade. Like, I don't really know. That's not what I do. So all we do is just developing the actual render, and the licensing bit, you're going to have to talk to my colleagues at Autodesk about that. As far as I understand, you can use Arnold, like if you buy Maya 2017, if you download it, it comes built in with Arnold, and you can do interactive rendering, and you can play with the render, but you might not be able to do batch rendering. So, no, like if you just want to do IPR, it's not watermarked. You can actually use the render without a watermark. What I think you can do is use the batch render.
Yeah, right now it seems like it's only in interactive session. So
right.
It's not going to work.
I think you can also save images and maybe even do animation sequences, but lock in the Maya UI or something. I'm not a Maya expert myself, but you probably talk to my colleagues here at Autodesk.
Thank you.
Hi, great talk. I just have two questions that are much less technical, but I'm very interested in your answers. You've had a lot of success with Arnold over the years, and I'm wondering, in your opinion, what would you say is your proudest moment with Arnold? And then additionally, if you're thinking pie in the sky, big dreams about rendering in general for the future, where do you see the future of rendering? That's a huge question, so any way you'd like to answer that would be interesting.
Wow. Yeah, so my proudest moment? I mean, it's been a non-stop, proud moment kind of thing. Like ever since I started working on Arnold, I could not believe that people were doing such great work with this little render that I wrote. It's magical to see the code that you write being used by all kinds of people every day. So every year there was like a better, a cooler project using Arnold, and I couldn't even believe that. I was really happy to see the adoption of Arnold. So almost every day has been my proudest moment. So that's great, and I hope that's going to continue. Now, as far as the future for rendering, pie in the sky kind of thing, I don't know, there's many ways to answer that question, but from a technical point of view, today most renderers use what we call the unidirectional path tracing algorithm. There's a ton of research on better algorithms like bidirectional techniques, and there's a lot of people working on these better algorithms. And some of these algorithms work great. They work even better than Arnold on certain scenes. When there are, for example, difficult lighting conditions, when there's like a small window or like a door that's almost closed and there's a light outside and the light reaches this room through a small hole. So there are techniques to handle those situations much better. However, still today, there's not one single algorithm that works, great across all of the possible situations. So someday, somebody will figure out an algorithm that's as efficient as the one that we have right now, but also covers all of those difficult lighting situations. Because like if you're here at SIGGRAPH, you can go to the paper session and people are going to explain more complex algorithms, but these are algorithms that only work well in specific situations. So what we need is a single, unifying algorithm that works across all of these difficult lighting situations, and it does not have many complex parameters and knobs that the artist has to deal with. So I didn't mention in this talk, but the cool thing about Arnold is that it's got very few parameters. So for a lighting artist that's not very technical, that's great because he doesn't have to understand how the technology works under the hood. An artist is an artist. He just wants to make cool pictures by moving lights and doing great models and shaders. He shouldn't need to understand the mathematics behind the render, right? So what I'm looking for is a single new rendering algorithm that works across all these possible situations with very few parameters, and it's as efficient as what we have today. So today, nobody has a good answer to that problem. So it's still an open problem. That's why we still need more research. That's why you guys here at SIGGRAPH need to present more research. Well, I don't know how many scientists are here in the audience, but the reason I come to SIGGRAPH every year is to hear what these scientists present every year, and we still need more work. Like, I remember many years ago, like 20 years ago, whatever, when I was starting working on Arnold, somebody told me, why are you working on rendering? It's a solved problem. You shouldn't work on rendering. It's a boring problem. It's solved. Like, I don't know. I don't think it's solved. So 20 years later, it's still not solved. There's still more work to be done in rendering. So we need to continue to do research.
Thank you.
Hello, great presentation, and I'm glad to hear the answer to that question. You're still working on the Make It Good button. That's good to know. I was wondering, where's the best place to go to learn Arnold?
Well, there's many places. So we have an educational program, and we have partnerships with many academic institutions all over the world, here in the US, but also in many other countries. So I don't know where you're based, but in our webpage, there's like an educational section, and you can see a list of all the institutions that teach or have Arnold in their curriculum. So yeah, I would just recommend you go to our website and look for the educational webpage. But there's many universities and private schools that teach Arnold. And I think that's only going to get bigger, because now that Arnold comes with Maya 2017, all of these educational places are just going to, okay, Arnold's right there, so we should teach it.
Yeah.
So because all the students are going to have access to Arnold. So I think it's going to get a lot more popular in the educational realm.
Okay, great. Thank you.
Thanks.
Hey, I had a question about the GPU rendering. So it looked like in the previous picture, there was a reflection missing on the medicine cabinet.
Mm-hmm.
So is that, I know it's an experimental thing, but is that, was there like a, secondary bounce that you couldn't do there, or what was the reason for that?
Just a bug.
Okay.
So I wouldn't pay too much attention to that. It's just there's no significant reason why that's there. We're just experimenting with the prototype. It should render the same exact image. Save for some difference in noise, it should be exactly the same. There are a few things that are difficult to do on the GPU. Like the more complex the algorithm, the more difficult it is to implement that complex logic in the GPU. So it's easier to just do standard ray tracing and just basically trace rays and do like a very simple unidirectional algorithm. But things like ray trace for surface scattering can be a little bit more difficult to implement. So that's why it takes so long to port a render to the GPU. So it's easy to do a simple render on the GPU, but it's very difficult to get a production render with all of the bells and whistles that a production render has and put that on the GPU. It's really difficult. For example, things like texture caching. Like one of the reasons why Arnold is so great in production is the amount of texture maps that you can load and use at render time. It's very difficult to get that texture caching system and map it to the GPU. You need to rewrite it. Like the system that we use is called OpenImageIO, which is an open source project that only runs on the CPU. So, you know, there's a lot of components in the render that have to be handcrafted and rewritten for the GPU. It takes a long time. Neither. I mean, this prototype uses something else, but I'm open to exploring all of the. So, in the GPU, you can use CUDA, OpenCL. You can use a number of libraries that have been written by different people. So there's many ways to write a render for the GPU. We're going to take a look at some of these techniques, and we don't yet know which one is going to be better. Some of these, like CUDA is a more low-level way to write a render, and you can probably get a faster performance if you write something in CUDA than if you use something else. So we still don't know which of those ways to write a GPU render is going to win. So the way we're designing this thing, we're doing it in a way that we're not going to be tied to a particular architectural system. So it could be CUDA, it could be OpenCL, it could be something else. We'll see which one makes more sense. Again, the problem is that each of these things requires to rewrite the whole thing again. So, it's just a pain to write the same code for all of these different architectures. It's not the same code, it's different code. That's why it makes it so difficult. It's a pain in the ass. I would just rather just write the code once, and so it would run everywhere. But, like if you can do that with OpenCL, for example, but then performance might not be the best. So, I don't know. Still an open question. Again, that's why it's taking us so long to write the GPU code. So what else? Yeah, we announced 3 Studio Max support yesterday. You can download that from our website. It's just an early prototype, but it would be great if you guys try it out and let us know how it works and if you find any problems. One of the things why Arnold. So Arnold is great not just because of the technology, but also because of the people and our support. So we love to hear from customers. Like if you guys try the software and there's something that doesn't quite work or you don't like, we like to hear from you, because if we don't hear from you, we can't improve the software. It's not just writing code, it's also keeping an ear to the ground and listening to what people need. That's how, over the years, that's how we've made Arnold so great. Not just because of the code, but it's just because of our, you gotta listen to the artists and what their problems are. I'm not saying that we can solve all possible problems immediately, but if you don't listen to your customers, your product's not gonna improve. So, let us know. Please talk to us, and we'll be very, very happy to hear from you guys. Not all of you at the same time, but the thing about Arnold now in Maya and Max is that we're going to get suddenly access to many, many more users. Like there's like hundreds of thousands of people with access to Maya and Max. So I'm a little scared about how that's going to run up. But we got a great team out of this that can handle that scale. So hopefully it'll be great. Any other questions? You guys want to hear about, I don't know, effects? Hey. Oh, cool. Cool. Well, if there's no more questions, I think that's it. I'm going to stick around for a while if you guys want to talk in one-on-one, and thank you for coming.